Morning, everybody here. And it's the 17th NCB International Conference Cement Concrete Building Materials second day and the second session. Going to be very important because it very directly relates to the main theme and main focus moving towards net zero carbon emission. And a very common word that's said about this industry and the steel industry, hard to abate sectors, and what's make it more important. So here our, combined collective, wisdom and the all industries, what's the way ahead and how we will be achieving the direction. So it's indeed an honor to be part of this panel and moderator for this very distinguished panel that includes diverse areas, practitioners, my colleague from NITI, industry leaders, academic from IIT Delhi and CV and this. So DG already introduced the panel members, Shri KJ Patel, who is already in a very key position relating to the one of the key raw material that's probably available for the industry, gypsum, and this is a kind of byproduct from IFFCO Paradip. So we'll be discussing more about that. Ms. Madhumita Basu, Chief Strategy Marketing Officer from one of the leading cement manufacturer, Nuvoco Vistas, and heading the strategy and marketing function along with the investor relation and ESG. His specialties lies in the sales, marketing, brand transformation, change management. We have very distinguished Professor Dr. D.N. Singh from Department of Civil Engineering, IIT Bombay. And his specialization is in very diverse areas: geotechnical engineering, mechanics, soil characterization, contamination, contaminant transport in porous media, mineralogical area. Very distinguished publications, 338 articles, 41 doctorals and master thesis, 35. So we have very rich experience and it's a very highly interdisciplinary area. And this geotechnical, I was just going I was just interacting, and it's such a distinguished outstanding contribution medal 2022 IAC MAG. It's International Association for Computer Methods and Advances in Geomechanics. And this award is given after a gap of every 2 or 3 years. So it's a very rare distinction that he had. Prior also 2011, from the same body, he was given a kind of excellence award. We have Shri Sanjay Pant, at very core of the standardization for BIS, from BIS 3 years experience, civil engineering, and anybody and everybody who is civil engineer, he definitely from the very second year, third year of the engineering knows about the National Building Code of India and the Concrete Code 456. This 456 is such a common that everybody knows it by heart, most of them. Then we have Professor Parida, Director, CSIR-CRRI, and specialization lies in the mitigation of mixed mode traffic noise, and he has been consultant to more than 350 urban road infrastructure projects. So what kind of material, what kind of industrial waste byproduct that can be very gainfully utilized in the infrastructure projects will be having experience of his professional expertise. We have Dr. Neeraj, Sinha, my colleague in NITI Aayog, and more than 34 years of experience. Previously, he was with the MNRE for 9 years, handled diverse range of activities and new and upcoming technologies, and he was actively involved in National Action Plan for Climate Change, which was released by Honorable Prime Minister of India in 2008. Corp, he has also, it's very rare to find very, very core officers with scientific temperament in, say, NITI Aayog and other ministries. He has authored more than 32 papers and recently awarded doctorate also. So it's a welcome moment to him. We have very, very distinguished officer from NCCBM, Dr. Chaturvedi, and more than 36 years of experience, diverse field of research, planning. Presently, he is unit head of NCB Ballabgarh, and he is a organizing secretary for this conference also. He is also credited with 13 patents, 120 research publications. So we can just welcome all these panelists here that will be getting enriched by their experience and going forward how and what directions the cement industry can take in terms of application of circularity principles and, and how the circularity related areas can contribute towards net zero. So that's the broad agenda, and that will be the broad conversation. So the context is, I think, it's such a common theme these days, and not only these days, it's being discussed, dwelled, and thought about for last many years, and there has been a very distinct realization by industries, all the leading industry players in the cement sectors, because all their sustainability report now very clearly articulate going forward what are the directions, the strategic directions they are going to take. Parallelly, a lot of a very characteristic feature of the industry is that lot many raw materials as well as the alternative fuels that are not so desired many times by the other side of the other counterpart industries, and they becomes very, very, very useful materials that turns out to be a very valuable material that's called cement. And India means a lot of urbanization has to be there in the coming decades, and that momentum will continue, of course, and how we really manage the growth as well as the zero emission targets that we are putting up, that's a counterbalancing act, and how we'll be achieving that, there lies our ingenious efforts and the kind of strategy the industry adopts. So we have, and going forward also, we'll be having a lot of industrial byproducts in a diverse range, approximate 65 metric tons of legacy phosphogypsum that's being there with the fertilizers plant. 8.5 million tons is the annual generation in that sector. So we have to find ways and means to gainfully utilize that. Similarly, aluminum industry produces red mud, fly ash. That's a very, very, very big challenge, but that has been, say, utilized up to 95%, more than 95% in the economy, but going forward also we'll continue to have these waste streams. MSW, municipal solid waste, again, a part of it can be gainfully utilized for the alternative energy sources. And not only the cement sector, how the cement work out, it's the construction sector, a lot of construction demolition waste. I think more than 4,000 metric ton annually is per day is generated even in Delhi. And our 3 construction demolition plants, either they are, means there is a learning around those plants, what kind of material they are, handling, and what kind of secondary materials they are doing, and how we can have a better applications and markets for the secondary materials. So it's a very diverse area. Circularity, it's a very highly interdisciplinary, and a lot of collaborations, coordinations, and really many times the real scientific work also need to be parallelly carried out. So these are the broad challenges, and given this perspective, NITI Aayog, we also gave a lot of attention to these, how these growing quantities of the industrial byproducts or the waste streams, or how the circular economy principles of reduce, reuse, and recycle can be applied for our evolving manufacturing landscape and the urbanization landscape. So in 2021 April, NITI Aayog constituted 11 committees in areas that continues to pose considerable challenge or are emerging as new challenge areas, and that need to be addressed in a very holistic fashion. So 11 interdisciplinary committees, they were set up under the ministries headed by either secretary level or additional secretary level. These were the municipal solid waste, liquid waste, scrap metal, ferrous, non-ferrous, electronic waste, lithium ion batteries, solar panel, that's a upcoming waste, and gypsum. We have legacy waste as well as a new stream of gypsum coming up through the power plants desulfurization direction. Another is toxic hazardous waste is again a continuing challenge, and we are prioritizing the hazardous waste that need to be dealt with a very professional and a very holistic manner. In many of the countries used oil waste, again that waste stream also goes more than 1 million ton per annum, and this can be very gainfully utilized in a circular economy by recycling of waste oil. And everybody in Delhi knows that agriculture waste last 5-7 years, how it impact the air quality in November, December, and in the winter. So these are the broad challenges, and how the circularity principles can be applied, or the industrial byproducts, how they can become a feed to the another industry. So that is a larger framework in simplified terms. So in a way, cement industry being at the center of circular economy framework in our country, and it utilizes many waste streams. So that's the perspective, and the challenges and bottlenecks in utilizing the industrial and byproduct exist either due to lack of implementation or scalable technological solutions or regulatory or policy issues that are causing impediments in adopting the new technologies, or many times it's the incorporation of the scientifically proven advanced innovative new technologies in the standards or manuals of BIS, IRS, or CPWD procurement standards. So there are multiple issues. It's not only that if technology is proven, something is proven, then it will find market, or it will find procurement, and it will find applications at the end side. So these are the myriad natures of the challenges, and in this context, the question what we propose to deliberate, or we propose to pose to our distinguished panelists are, what are the roles of circular economy in sustainable development? Or we can relate it to our net zero, the conference all about. And what are the interlinkages of cement and construction sector with other industries of the economy? What is the global scenario and the best practices of circular economy with focus on cement and construction sector? What are gaps and challenges for circular economy in Indian cement and construction industry? And what aspects should be prioritized to promote circular economy in India? So that is the broad canvas of questions that we'll be proposing to my distinguished panel members here. So it's a very, we'll be moving in very different directions, but they all converges to one single direction, and that is how much the circular economy can contribute towards the net zero. So there is no clear estimation as on date. Somebody say it may be 1/5, around 20%, it may contribute little more or less. We have not done any kind of very systematic study on that, but these are just guesstimates. But going forward, definitely being a very important segment that already have experience to deal with such diverse range of raw materials and alternative fuels. Let's get enriched from our panel members. Let us have a big applause to the members here. So I'll be, broadly putting up some simple questions, starting with something with our most distinguished panel member here, Professor Dr. D.N. Singh, about the what the role circular economy in sustainable development with particular focus on cement. And before this meeting, he was conversing that out of deliberations, what we had last year's, many new ideas and suggestions are very practical that may be applied. Thank you.
So thank you very much for giving this opportunity to speak out my mind and heart in the form of this panel discussion. I'm very happy to see Dr. Gupta over here, who has been my collaborator, and he is the one who encouraged me to take my ideas out of the classroom to the national forum, I would say. And Dr. Gupta, if you remember, then we had two discussions at IIT Bombay, where NITI Aayog was involved. Dr. Saraswat was there whole day, and you were also there, and we came out with a good note, which I think I'll be circulating to the organizers, and they can forward it to everybody. The question is, what is the role of circular economy in sustainable development? What I realize is that without economy, we can't live, and with linear economy, we have already lived, and we have realized that we have failed. So it has to be circular henceforth. We have to understand what is sustainability. And sustainability is very difficult to realize than to define and to teach in the classrooms and to the corporate. Coming to the cement sector, based on my discussions in last several meetings, I have realized that, see, we have to offload cement sector from the unmindful creation of the waste which we have done. Because cement industry cannot absorb everything. That means we have to look for something which is in bulk. And that's what actually I'm championing. Well, some part of the man-made resource, which is waste from the industries, can be used by cement industry. But the bulk has to be utilized in the form of the man-made soil. And this is to be done by the infrastructure sector. Now, when we talk about infrastructure sector, we have to marry different types of waste products, industrial byproducts, which have to create sustainability. A good example would be, I come from the coastal region of the country, Bombay. And when I discuss with most of the ports, the biggest issue is what to do with the dredge sediments. Millions of tons of dredge sediments are being produced because of the maintenance dredging. If you don't maintain your channels, the economy of the country will get affected because the ships cannot come to the port. This is from where the economy starts. I can't discard them. I can't store them in the premises of the port. So what should I be doing? I should be creating something interesting out of it, which falls now in the premises of, in the preview of Sagarmala project. If I can utilize this material by judiciously mixing it with some other industrial waste which is lying here and there in the country, I can create an offspring, a good material which can be utilized for infrastructure development. And I hope you'll realize that the country is not infrastructurally very developed. What is the bottleneck? The bottleneck is the mindset, because we have always considered this as a untouched material. Now we have to come out of it. So circular economy related to the waste or the man-made resource, better to say, is going to be the answer to the situation. I was just discussing during the tea break. The biggest question is how to transport the material from one place to another place. And this is where we will discuss about the ideas where we have to create some sort of, satellite centers for each industry where the waste can be taken, kept, processed, and marketed. So your circular economy concept is going to be successful once we create marketplace. And this marketplace in today's IT world can be done very easily. Each and every material on this earth is a resource. Nothing is a waste material, provided we know how to utilize it. With this, I'll stop at this moment. And I hope you must have got my views on what is the circularity associated with the industrial byproducts. In fact, the municipal solid waste also falls in the same category, because there is a possibility where I would like to utilize the phosphogypsum which is coming out of Mr. Patel's industry, and I would like to utilize the red mud from the Hindalco, and I would like to utilize the bio-mined waste from the landfills to create a man-made material which is going to be the best possible fertile soil. Thank you very much.
Hello. Yeah. Thank you, Professor Singh, and you have set the tone for the discussion, just giving overarching thoughts on, how the sustainability connects to the circular economy and man-made resources. Now, my next question is Dr. Neeraj Sinha, my colleague NITI, that while discussing, we had main discussions on the same subject, that what main challenges for transition from NITI, from circular to the circular economy in India, and do the necessary regulatory steps taken, or what more need to be taken in this direction?
Thank you, Sudhir, and first of all, a big thank you to the National Council for Cement and Building Materials for number one, having organized this very topical conference, and number two, having thought NITI Aayog to be fit enough to be invited and to play some role from the dais. Before I actually attempt to answer this question, let me also confide and confess that the actual person who handles this subject in the NITI Aayog is my colleague. And Mr. Sudhir Kumar is responsible for promoting circular economy in the Government of India, and of course in the country as a whole, including the states. And when I realized that all these questions relate to his subject, I was pestering him for the answers since yesterday. But like a good teacher, he never gave me the answers, he gave me a lot of material to study. So I've been doing that since yesterday, and I've arrived at some answers which I hope should address the question. I've framed them on my own. First, the challenges. See, for anything that we do in India, and for anything that we do anywhere in the world, we first need to have a change of mindset. We have been used to the so-called linear economy of behaving and living for probably centuries. Now, suddenly we are made to realize that the environment is as important to us as anything else in this world. If we keep on depleting the natural resources the way we have been doing, then we'll be ending up with nothing to play with maybe a few decades from now. So mindset change is something that comes not only in the government, but also in the industry, and also in the academia, in our R&D system, in all our colleagues who actually do research on various technologies, who also help us in translating technologies from the lab to the industry. So that is, for me, the first challenge that comes to my mind. The second is, we know that for anything that we know, we need resources. Now, resources would mean human resources, it would mean financial resources as well. I'm told by Sudhir that a lot of work is already happening, especially in the automobile sector. For electronic waste, we have had the so-called mechanisms to take care of electronic waste for some years now. But automobile waste is something which is now gaining prominence. Major automobile industries have started setting up scrapping units. Maruti Suzuki Limited, Tata Motors Limited, to name a few. So we need to look for resources, and the government's duty is to help the industry in looking for them. While the government cannot fill up all gaps, but it can definitely facilitate the industry to fill up the gaps jointly along with the government. So be it human resources gap, be it financial resource. And the third is, we already have guidelines in place. There is a rule also in place which I'll just read out. But then these guidelines are generally not mandatory. We know that enforcing anything on anyone is not looked at kindly. But in due course of time, as we go along, the third challenge in my view would be to transform these so-called guidelines and frameworks into rules and mandates. And this will be done over a period of time, obviously, when we are able to take care of the earlier two bottlenecks that I mentioned. And once that happens, I think we are in the driver's seat to take care of circularity in all sectors of the economy. Now, the second part related to what are the various regulations. So, I'll just read out a few of them. There is guidelines on the usage of refuse-derived fuel in various industries, and this was published by the Ministry of Housing and Urban Affairs in 2018, 4 years ago. And then there is a guideline document on Uniform Framework for Extended Producer Responsibility, EPR as we call it, under the Plastic Waste Management Rules of 2016. Now, these were rules published by the Ministry of Environment, Forest and Climate Change. And finally, in July 2022, just recently, on the 21st of July 2022, the Ministry of Environment, Forest and Climate Change has notified the extended producer responsibility for waste tire. And this has come into force from the date which I mentioned, July 21, 2022. So these are some names that I could catch from the reading material given to me. If I'm missing something, I'm sure Sudhir will supplement. Thank you.
Yeah, thank you, Dr. Sinha. Yeah, this is the 2022 is an year when the Ministry of Environment, they introduced extended producers responsibility to two new areas and revision in the guidelines for the plastics and the e-waste. So this is a very distinguished year, I would say, and maybe one more guideline might come, hopefully. So this is a quite lot of regulatory work that has been done by the Ministry of Environment. Now I come to Ms. Madhumita Basu, Nuvoco Vistas side, one of the leading cement producer in the country, and took lot of initiatives in the alternative fuels also last year, this year also. That's what I read from the reports. And my question to her is that how cement and construction industry is interlinked with other industries like aluminium, iron, steel, fertilizers, and generating all these byproducts for the cement industry, and the potential for further enhance the industrial byproduct utilization. Is your company's strategy very actively look forward that what potential lies for these industrial byproducts?
Hello. Sudhirji, thank you for your question. I am conscious of the fact that there is a highly talented panel on this stage. And before I jump into the question, I think I owe it to the audience to present a little bit of credentials to speak. And on this subject of cementitious material and blended cements, Nuvoco Vistas Corp Limited, our cement to clinker ratio is 1.8 plus, where the all India average is 1.4. So you could say the company looks at blended cements with a kind of passion. Given the audience here and given the panel, I'll not get into enumerating more on the waste from Hindalco or the waste from Tata Steel and how it's being used in blended cement. It's just too fundamental for me to bring to the panel. But in terms of what can be done more, here I will pick up a statement from very interesting Professor Santhanam's address just before this panel. And if I remember rightly, he said that use of OPC in his judgment is criminal. If I might say so, I second the judgment. So stopping OPC, just stopping it. And here I have Professor Pant, yourself, Professor Sinha, to support me that you have to challenge the industry. So when I talk about our credentials with pride, I am also humbly conscious of the fact that we are an East dominant industry. Availability of slag is very high there, and the company takes pride in utilizing slag in the region. But if you stop OPC, you will challenge the industry to look at more options. I have Shri Pantji here on the panel, and some yeoman work has been done collectively with IIT to look at LC3 cement. We need more blended cement options, and we need direction for stopping the use of OPC. So a lot of exciting things happening. Nuvoco as an organization looks at circular economy, firstly at a very low-hanging level of not going in for OPC production and sale. Largely limited holistically. However, the propensity to use OPC is still very high in the northern parts of the country, and something like use of kaolin clay there, which is abundantly available, would be a good breakthrough we are looking forward to. We're also passionate in the area of waste heat recovery. All our IUs have waste heat recovery systems, and at 2+ megawatt per million ton of cement, we are touching the benchmark in WHRS capability and performance. And finally, AFR. So if we take a look at some of GCCA's published figures here, we learned that internationally, AFR substitutability is as high as 19%. Globally in the country, it is a little under 5%. Our best unit at Chittor is knocking 30% today. We do need to do some work in the area of pre-processing, co-processing, handling equipment in 2 of our plants, one in Nimbol in Pali and one in Rishta and Chhattisgarh, which we have already taken up. And between globally across the organization, between last year and this year, we've doubled our AFR TSR, and looking forward to exiting this year at something at a 12% plus, which would be a good measure of investment and work that would have gone into it. So in summary, the cement piece is good. We have a fairly large organized industry. I'd just like to touch on what Professor Singh said here, that how much more of the responsibility can you put on the cement industry? And here, Professor Singh, you'll agree with me that there is a lot that can be done at the concrete end, because really if we see the global consumption of concrete, that's where the consumption curve is going to increase at an accelerated rate. Concrete is also a production that takes place more spread out across the country. So if we can look at aggregate substitution, if we can take a look at the use of waste material, which is closer to the concrete end of the business, and the right kind of policies to support that, I think that's an area where we can still grow by leaps and bounds. Finally, when we talk about circular economy, we shouldn't speak just cement or concrete. We have to see the whole cycle, from mining to recycling of C&D waste. And there the numbers are really, really very low. I understand that there is some 60 million tons of C&D waste which is officially recorded, and barely 0.3 or 0.4% of this we have even capability to recycle and make available to the industry. So this collaboration and some policy support would greatly help the industry. Thank you.
Yeah. Thank you, Ms. Basu, for very relevant, and it syncs with the very holistic approach that need to be taken from the mining to construction, and how the end of life of construction, demolition waste, that's again a big challenge in the country, and we have to adopt many good practices that are very much prevalent in most of the developed economies. And a very common theme arriving that industry need to be challenged and change in mindset. So this is something that we have been doing something for many years. We have mastered certain management or other practices that don't mean that there is no other way to have better optimization or better way of doing the things. So many times we have to look the whole perspective again, redo many things, rejig many things. That's how we look at the different chains or the material chains. That's what the perspective is. And many collaborations and fresh thinking is required. That's what the input I gathered. So again, thank you. And now, I am moving to the Road Research Institute side. It's a very, again, a infrastructure sector, and we have been building quite a bit last decade, and going forward, again, this would be a major thrust. And here I would request Dr. Parida, Professor Parida from the CRRI, that what he has been heading the research side. So the kind of role the research institutes can play in addressing the constraints in implementing circular economy of industrial byproducts, and if he could highlight some of the new advances in constructing sustainable roads. So roads are their expertise, and that's what we want to hear, what's new in the roads.
Thank you, Mr. Saur. First of all, I would like to thank NCCBM for this opportunity to share my viewpoint. I'll just stick to one particular type of waste, that is steel slag. Central Road Research Institute has been very active in utilization of steel slag for road construction. And there was a very good model. Professor Singh talked about challenging industry. So I'll put it in a slightly different way. The model is that it's a project, research project sponsored by Ministry of Steel with partnership of 4 industries. So Tata Steel is in the audience, then JSW Steel, AMNS India, Rashtriya Ispat Limited. So these 4 were partners. So they had different kind of slag. And the basic mandate in the project was to process these different kind of slags for road construction. And very recently, Tata Steel has, they have shared 1,600 tons of steel slag on 2nd of November, where the steel slag is being used for road construction in Arunachal Pradesh by Border Roads Organization. So, these kind of developments, these kinds of projects, they really help when industry and the ministry, they come together and develop the project. So that generates the confidence. And while Mr. Saurav Kumar asked the question, I was trying to aggregate the numbers. Against a steel slag production of 20 million ton, the usage is not more than 1 million ton. If you try to put all the usage, after the work of the steel slag research, now different steel industries, they have got contracts by various road concessionaire, but still I'll put the figure way less than 5% of the total steel slag which is being produced. And coming back to an institutional mechanism, besides BIS, the road construction standards are framed by Indian Roads Congress. So there is accreditation of new materials committee in IRC. So they essentially look for test certification from CRRI, from IITs, from NITs. But besides the lab test, what is very important is looking at the data with respect to the long-term performance of the trial stretches which are being developed. So here the industry can play a very good role, especially on the concrete sites. The Honorable Minister of Road Transport is very keen for development of cement concrete roads in the country. So if you try to develop more and more trial stretches with active participation of industry, so it's going to generate enough confidence with respect to the possible gray areas with respect to these steel slags. And I'm sure Central Road Research Institute can partner with respect to deployment of technology on the ground, then third-party audit, and capacity building in various stakeholders. So these are few points I thought I'll share, but it is just with respect to steel slag. So for other slags also, it is possible that the research institutes, academia, IITs, NITs, they can work very closely with the industries. But obviously, this particular steel slag research has been possible with the support of Honorable Dr. V.K. Saraswat, member NITI Aayog. So I'm sure these kind of panel discussion, deliberation can lead to such sustainable model for developing the research projects around utilization of waste material. Thank you.
Thank you, Professor Parida, and very insightful kind of developments, kind of directions CRRI is taking for validating and the performance relating things that are very key for the infrastructure. The kind of materials we use, we have to be really confident enough that these all new infra projects with new materials, alternative materials will perform at a fairly high level and would be beneficial in overall terms. And capacity building is another area where, this is something many times neglected, and if there has to be a very close industry-institution relationship that things what are being developed are adopted, transferred to the industry side, and industry side, whatever the new challenges, the new competitive challenges, and whatever best is happening across the world is, taken up at earliest, and we also share our best practices to many other countries who look forward. So this is one of the key institutions we have in the country that has been working for long in the road sector and doing a lot of what he mentioned, a new chapter within the IRC. They look forward for the new materials and how they can be deployed. So these are the insights, and NITI Aayog, we also kind of, I remember 2014, Dr. Saraswat specifically, pushed the steel ministry that they should get the standards for these steel slag applications in diverse areas. One of the area identified was whether it can be used in the road sector. So this is something that many times if we articulate that we have to look for solutions, then solutions come up. So it's our ambition that many times determine that what we will be achieving. So thank you again, Professor Parida, for sharing all these insights. And now we come to the IFFCO side. In the cement, a very useful material called gypsum that either come from the mining side or there are industrial byproducts also. So this is a byproduct that we have been keeping at our backyard, kind of piling up happening. But definitely we have to solve our legacy issues. Perhaps this is the time that we should look for very serious, in a serious way. So I would just like to ask, what are the challenges and bottlenecks in achieving circular economy industrial byproducts like gypsum? Say, is it the first time that we are looking on this issue very seriously, or there have been some attempts, successful or not so successful earlier also? And when India is importing about 5.8 million tons of gypsum, can we really substitute by the available gypsum that's coming as an industrial byproduct? To Dr.
Thank you, Shri Sudhir Kumar sir. First of all, I wish to communicate my thanks to NCCBM, especially Dr. Mahapatra, for giving me an opportunity to be here. We are the operators of the fertilizer plants in the country, and IFFCO being the largest producer of fertilizers, we own the responsibility of the food security of the country. As far as the phosphogypsum generation is concerned, the majority of the industries, including IFFCO, PPL, and Coromandel Fertilizer and Green Star, which are the four major industries of fertilizers, who are producing phosphoric acid, which is one of the important intermediate product for producing finished fertilizers. So when we produce phosphoric acid, for a ton of acid to be produced, we have to produce nearly 4.5 tons of phosphogypsum. And that phosphogypsum is required to be stored, maintained, and ensured that there is no challenge to the pollution and the environment surrounding the fertilizer plants where we store it. The way out to get rid of this phosphogypsum is either we dispose it off or we stop generation of the phosphogypsum. As far as generation of the phosphogypsum is concerned, I would like to inform that in our country, we are already having shortages of fertilizers to meet within the domestic productions. So we are importing nearly 6 million tons of DAP fertilizer, especially from outside the country to meet the requirement of the country for food security. So we, being the 35% contributor towards the fertilizer production need for the country, obviously the generation of gypsum from this phosphate generation is increasing day by day. And we are trying to meet the requirement of fertilizer because due to recent geopolitical situations across the world, the availability of the fertilizers even in the international market was very limited. Then we had the responsibility to increase the productions of fertilizers, and through that another additional phosphoric acid generation was also required. Now with all this background data, we have as of now more than 50 million tons of legacy stock of gypsum with us. There were two main challenges and bottlenecks in front of us, and that was as the industry is located on the east coast and we being very close to the coastal locations, because most of the raw materials, majority, more than 90% of the raw materials what we receive, they are all from outside the country. Now this gypsum, whatever stock we have, that is also required to be stockpiled in a location where there is already shortage of land. We want to dispose it off. Now for the disposal of this legacy stock, what can be done is there are two options. One is that within the purview of the unit, how we can make sure that the disposal is expedited. And in order to expedite the disposals, the main bottleneck was the logistics. That how can we improve the availability of the logistics solutions? The railway siding is concerned, our IFFCO's unit, which is the largest producer of the world as far as the phosphoric acid production is concerned, and we do not have the rail siding within the plant premises, which otherwise IFFCO had in rest all the 4 plants in our country. Since this particular plant was a purchased plant, to avoid the loss of the national asset, we took it over as a challenge to revive that plant which was stopped and closed in the year 2005 by one of the private operators. What we did is that we had identified the ways and means that how can the logistics be improved. So there were 2 options for us. That one is the closest available river, that is the Maha River, close to our plant. So from there, if we establish a river jetty, and we had an MOU with Paradip Port Authority, that if the railway siding of Paradip Port Authority can be made available to us, we want to start a logistic solution utilizing the help of our Inland Waterways Authority of India. That NW64 is very close by to us, and we invested and immediately started a river jetty operation through which we could transport more than 4,000 tons of gypsum from the plant site to railway siding. Now this is not going to solve our problem because our generation every day is nearly 14,500 tons. Rest of the gypsum which is required to be transported to various customers, especially the cement manufacturers. I must thank the industries from cement sector that they are helping us to dispose it off. But for challenge of transporting balanced quantity of gypsum, we invited the request and the availability of the land in the nearby area of the industry like ours, that is also a scarce. And so with the help of the Container Corporation of India, we could locate a land where we have established the railway siding, where right now 2 numbers of rail siding facilities are under construction, which are likely to be completed by 31st of March next year. And we will be able to start disposing of nearly 8,000 tons of gypsum every day, because each siding can handle minimum 1 rake. The major bottleneck is how to make available these rakes for transporting gypsum from these sidings, whether it is from Paradip Port Authority railway siding or our own railway siding located in the Concord area. So for that, we are discussing with the Railway Ministry. Due to recent requirement of the coal movement, the availability of rakes even for fertilizer movement were very limited. And now with the more than 1 lakh wagons being ordered by railway with our pursuance, the situation is improving day by day, and the disposal is increasing from our railway siding at port as well as through road transport. Second major challenge is the quality of the phosphogypsum, because we had discussed a lot, and Dr. Gupta is here. When he was steering various sessions, and Dr. D.N. Singh was also there. So we were discussing, and the quality of phosphogypsum should be such that it can be readily used by cement plants. How to make phosphogypsum to that quality level. Unfortunately, the rock, which is a raw material, is not produced as per our requirement. That's not a tailor-made product. It's a naturally mined product outside our country. We have to get it. And when we get it, we have to follow a certain process licenses technology, which is available with Jacobs in USA, or it is with Prayon in Belgium. We are following Jacobs USA technology. Now with that technology, whatever minimum water-soluble P2O5 especially, which could be brought down with the best performance as far as the characteristic of our process conditions are concerned, we manage it to bring it down below 0.35%. The industry wants 0.25%. Now that cannot be achieved because of by any means utilizing these chemical equations and reactors conditions within the fertilizer plant, especially our P2O5 plant. The agricultural use of gypsum, that is also one very important resource, because gypsum is also declared by Fertilizer Control of India, Fertilizer Control Order by our Department of Fertilizers, that it can also be used as an agriculture fertilizer. But the level of knowledge and also the kind of soil, the soil testing is very important. And we get now the services extended to the farmers, to their doorsteps. We have mobile vans which we take to the doorsteps of the farmers, and we provide them that, yes, let us get your soil analyzed. If the sodic soil or the soil which requires gypsum as one of the fertilizers, we are promoting it so that we can bag this gypsum. We have been bagging it, we are supplying it to UP, Bihar, and there the farmers are quite trained. They are receiving it and they are very happy to have it more and more. Unfortunately, the challenge is the cost of transportation. If we have to transport a gypsum which is sold at a very nominal rate of 200 rupees a ton, and the amount of money which we have to spend towards transportation, it is equivalent to a product which our fertilizer, which is costing nearly 80,000 rupees a ton. So a product costing 80,000 rupees a ton is also supplied at the same transport cost as compared to a product of gypsum which is just 200 rupees. So how can a receiver afford it? That is also a second challenge in front of us. The neutralization of the gypsum, if we have to bring it, the pH level of gypsum, which is normally 4%, plus or minus 0.5%. But there are certain fertilizers. We have a legacy stock. Our stock is more than 7-8 years old. Over a period of time, the acidity gets leached out through P2O5 draining. But there are industries where the fresh gypsum stock is also available, which has got around 3 pH. Now, how to increase the pH level? So that is also a major challenge in front of us. And I'm sure that the cement plants, because they are not very closely located to the east coast of our country, there are very limited quantity can be consumed by them, which are available with us within state of Odisha and all. But for rest of the cement plants, if we have to supply, we have to have the required infrastructure, and for that we are discussing and we are identifying the possible ways and means. Thank you, sir.
Thank you, Shri Patel, and very encouraging kind of feedback we got, that we got the plan for the gypsum sector concluded sometime December, and we have been all the circular economy plans that we concluded for the 10 sectors. identifying specific actions. So there were only two major, directions that we should have some kind of plan for liquidating the legacy, and he identified that there are two major challenges. Logistics is one, another is the 0.25 versus 0.35. So it's a technological challenge whether we can find out a way if it can be reduced. If there is, that's where the the support of the R&D institutions come. That we have to get 0.25 to make it useful for the cement industry. And parallelly, that report by the DPIIT that was led by and supported by Dr. Gupta it's one of the most comprehensive document that will be helping us, guiding us for at least for next 5 years, that where all the stakeholders, all the issues, all the scientific, technological work that's being done, and that they propose to do it for next few years. Like NTPC will be doing the research work for the new waste system of gypsum for next 3 years, that the gypsum, what is going to be produced, will be useful in what quantities, in what, so that there is no adverse effect on the soil side. And here the agriculture scientists and the ICAR is working with NTPC to find the right solutions, quantities, qualities that can be utilized so that soil fertility and the productivity is obtained. Another is the point that's very common to you, that you are finding land resources limited, means you are not finding any land, and that's the situation in all cities also. We don't have any places where we can, place our municipal solid waste. So minimizing the waste generation, if possible, that is the best example of circular economy principle. But if wastes are essential part of the, the processes, then we have to look for the next best alternatives to utilize them gainfully wherever possible, and to look for the better prospects. So, and it's again very interesting that you are going to have logistics to increase your capacity of take from 4,000 to 8,000, just doubling your, flow of material to the other side. So these are the really very encouraging things, and we'll definitely find more and more alternatives for that. Now I come to Shri Sanjay Pant ji, BIS, who are, I would be just giving a background kind of the work, the support we had from the BIS side in all the circular economy groups. In all the circular economy groups, essentially we had 4 departments represented on them. One was the MOEFCC, one very senior level officer, another from the CPCB, who implements the regulation in diverse sectors. Another was from the BIS. We knew it in advance that the BIS support for developing standards for all waste secondary materials that would be coming out will be very critical. So unless there are standards, we cannot trade. Waste, like any other commodities, it has to be traded, and it has to meet certain specifications, like mentioned by Mr. Patel, that if it meets 0.25, then it's okay. So we had a lot of support, and I think this year only BIS was working on more than 25 standards for the secondary waste materials and secondary materials. I would request Dr. Shri Pant to just inform the gathering and the panel the kind of steps that have been taken by BIS to promote utilization of industrial byproducts in cement and construction sector.
Thank you, Sudhir ji. Thanks to NCB and DG NCB for the opportunity. First of all, use of waste or utilization of waste is nothing new to standards. And if you go by numbers, IS 455, it means it was formulated in 1950s. We have recently become very active, but the standards have come in 1950s for Portland slag cement, 455. And in 60s, IS 1489 Portland Pozzolan Cement, 1966, 3812, that is fly ash, and similarly for other materials. So right from early 50s, we have already formulated all the standards. See, the lack of proper utilization was not because of standard, but in spite of standards. So we have to see that what is more required, along with standards, and that's number one. And today in IS 269, which is Indian standard for ordinary Portland cement, we have permitted, even for OPC, we have permitted 5% fly ash, granulated slag, silica fume, limestone, rice husk ash, metakaolin, copper slag, steel slag, lead zinc slag. Even from refinery, the equilibrium catalyst we have been permitting. We had permitted in IS 1489, that is Portland Pozzolan cement, up to 35% utilization of fly ash. And after permitting up to 35%, we could maybe some 20 years back, more than 20 years back, so it could be reached now. So we had put in place the projected higher utilization of fly ash in PPC some 2 decades in advance, as the technology develops, because it was possible. Similarly, the other materials like calcined clay was permitted in IS 1489 Part 2. The Portland slag cement IS 455 permits from 25 to 70% of slag utilization. And if you want to use more than 70%, even that is permitted. So you have another standard IS 6909. So even that is there. We have a new standards on composite cement, IS 16415, that permits both use of fly ash and slag. Coming to the aggregates that some of us talked about, we revised IS 383 in 2016 to permit use of various type of waste materials, as including the construction demolition waste derived aggregates, as part replacement of natural aggregates. So we permitted iron slag, steel slag, recycled concrete aggregate, recycled aggregate, bottom ash. So all these are permitted in today. So today you have standard available since 2016, permitting all these as part of the aggregates, at part replacement of aggregate, including from construction and demolition waste. Now it's a matter of utilizing the provisions which are already available. We have IS 9142 on lightweight aggregates, including slag-based aggregates, separate standard because these are lightweight, so it have not been clubbed in 383. We have the sintered fly ash aggregate standard, IS 9142 Part 2. Now, you would also be glad to know that some of the BIS certification licenses with ISI mark have also been granted to some of the units for even sintered fly ash aggregate, even to the aggregate as per IS 383. See, the idea today is not only we should have these, we should have competing materials and competing technologies. It will also, as you said, sometimes transportation is the issue. Sometimes local skill will be an issue. Somewhere local availability will be an issue. And therefore, we should have competing materials and competing technologies to be built, to be used alternatively in varied combinations. And therefore, if you want to make a, say, masonry wall, you can use IS 1077 as common burnt brick, or perforated brick, or hollow bricks. Or you can use fly ash cement, fly ash clay brick 12894. You can use fly ash that lime brick 12894 and 13757. You can use fly ash cement bricks, that is 16720. You can use stabilized soil bricks, IS 1725. You can use various concrete blocks with use of fly ash and slags already permitted in them. 2185 for solid and hollow concrete blocks. You can use 2185 Part 2 lightweight sintered fly ash concrete based block, or autoclave aerated block as per Part 3, or preformed foamed concrete block as per Part 4. You can use IS 12440, that is stone concrete block, which will use the waste stones from the quarries, and even that is permitted. We have GFRG, glass fiber enforced concrete, that is IIT Madras technology, for which we have a new standard, IS 17400. In fact, we made a standard, but the technology vanished from the country. So we tried to match with the requirements, and hopefully it will come back someday. So these are available. Now, we have standards on fly ash as a material, slag as a material, granulated ground blast furnace slag as a material, and ultrafine slag is also material. So these are all available, and these are cross-referred in IS 456 concrete code and ready-mix concrete code IS 4926. So these are already cross-referred. So complete network of information is also there where all these things. See, these are one set of material. There can be another set of material from the industrial or agriculture waste. We have plantation timbers to be used rather than conventional timber. We have social agroforestry timber. We have rubber wood. We have wood waste-based material. Even today, we have technology where you can use small waste pieces of timber and join together with a finger jointing. All these standards have been developed. The finger jointed section is stronger than the original sections. So you can have larger girth, larger sizes made available through all these technology. These are permitted to be used. These waste-based materials are permitted to be used in structural sections, in doors, windows, in furniture, in wood panels. So and for which also standards are available with Ecomark also. And we have today standards available for use of coir, jute and bamboo-based panel products. We have a structural design code IS 15912 for bamboo design code. So these are available and designs are being done. Only thing is scale, we have to go. So these standards are available, many more can be done and are in process. And we have standards for byproduct gypsum, that is IS 12679, which permits series of waste-based gypsum and including phospho gypsum, marine gypsum, FGD gypsum, and we have this standard for agriculture use of gypsum for reclamation of sodic soil also. These are available. But see, all this said and done, this is only one part, which is material. Sustainability is not only material. Sustainability is a much, much larger concept. It starts from external development. When you do a development, are you ensuring that in any development that you do not harm the environment? When say, rather than reducing environmental impact, we should talk about a development which improves the environmental scenario. For example, you had 3 ponds in the project, and you maintained, you did not fill up those ponds. You have now 7 ponds when the project finally concluded. You have 1,000 trees. After the conclusion of the project, we have 10,000 trees. So we have positive environmental impact because of construction. Unless we go to that level, these efforts will remain minuscule efforts. And therefore, we have to see that when we develop city, when we develop project, we take care of these. Are our cities cyclable? Are these walkable? Are these accessible for persons with disabilities? And are the balance between hardscape and softscape? Are the pavements are pervious? Have we managed the walkability and walking with the mass rapid transport system? And then only real thing will happen. Is your, in the morning you get up and fetch milk, is it within 1 kilometer or half a kilometer? Schools within 5 kilometer, offices within 15 kilometer, or we are going to another city, So we have to go to township level and state level and even country level. We'll have to ensure that when we come from township, we should not have a green building in environmentally not so compatible townships. So you have to have a township which is environmentally compatible, well-designed, preserving the flora, fauna, birds, butterflies, as it existed before the development took place. And when you go to building, you have to ensure the material part, as we discussed today. And we have to ensure the design part, envelope optimization. When you do construction, are we wasting the good earth or we are reutilizing at the same site or the other site? Are we ensuring that the water and waste management has been properly done, reuse, recycling of water has been done? Or even the building, if it is a complex building, are we able to use, if it is air conditioned, what kind of refrigerants we are using? What kind of the building performance tracking management that we are doing? in terms of water management, in terms of these management. So my submission is that standards are available, and these whole concepts have been built in Part 11, Approach to Sustainability of the National Building Code. So please see NBC 2016, Part 11, Approach to Sustainability, to get a complete glimpse of the overall concept of sustainability. Thank you.
Yeah, thank you, Mr. Pant. Introducing and informing the kind of initiatives that BIS has taken for this sector, and how the sustainability standard part also being taken care. So standards are there, and they are keeping, by and large, I think, pace with the need of the industry and the pace of expectation from the other developments happening. Like introducing the 5% fly ash and the OPC also, that way, impacting the kind of OPC side also. So last side is the something, from the NBC, Dr. S.K. Chaturvedi, that, our conference organizer also, and anchoring the circular economy initiative in the institute. Say kind of what thinking, what advancement you think that the cement sector is in India and globally for the use of waste as raw material. So it's a very broad question, but being constraint of time, maybe 5-7 focused areas that the institute want to take, and the kind of global developments that we can emulate.
Thank you, sir. And kindly allow me to be slightly philosophical while addressing this particular question. You see, the circular economy and sustainability, in my opinion, both are two faces of the same coin. And circular economy is not local. It is global in nature. Probably more needed in developed countries than we are in the developing countries. Now, coming back to the global issues first, you see, we had been discussing about the life of the structures, and we are very proud to say that our older structures are more than 1,000 years, they are still lasting. And our newer modern constructions, they are having limitations, 30 years, 40 years, 50 years, and so on. Let us be optimistic, let us call it 80 years life. Even if we take 80 years as a modern structure life, we need to go to the cycle of renovation, resuscitation, or again constructing the same thing again. The developed nations, which are already at the developed level, probably very soon, or maybe in few decades, they will be undertaking the process of reconstruction. So their research is focusing mostly on what are the materials they will be having at that moment of time, because the materials they had 50, 60 years back and the kind of practices they had that time are totally different. So their main focus is now concentrating the type of materials they will have at that moment of time, the type of construction practices they will be using at that moment of time, and maybe more recently I will say the construction chemicals. So these are the three focus areas where the global research is concentrating. Now, to be quicker on the Indian side, we had been working on the utilization of waste materials for decades. 3-4 decades we had been working. We have been working with fly ash, slags, and other industrial waste materials. And we have to come out of the mindset of waste very recently under the active guidance and support from Dr. Gupta and DPIT. We had produced a report on gypsum utilization. That is the first report, I will say, and you all will agree. It is the first report where the material which is going to be generated in future is being taken care of right from today. So we will have FGD gypsum, which will be coming into actual availability by the year 2027-28. But we have got the methodology and we have got the approaches, strategy, how to utilize that. So that is the best way of reducing what we are always calling legacy stock. With great difficulty, we could come out of the concept of waste materials. Now we are calling it the byproducts. If you see our reports, we are calling gypsum as the byproduct materials. Let us further come out of that concept and let us have these materials as reserve materials. They are our future reserves. When we say limestone reserves, this reserve, clay reserves, let this phosphogypsum, which is accumulated in the form of legacy, should be considered as a future reserve. Now, what is my difficulty? The research is continuing. When the problem comes, the research continues. There is a lack and probably need. Lackness is less, need is more. On how we can inventorize the total available materials in the country. We need to inventorize and characterize these materials so that they are put to the proper use. If today we find a material and suddenly some research says, oh, this material can be used here in making a brick or in making a cement, then probably tomorrow we'll say, oh, this material we have lost. We could have used it in a better way. So there is a think tank to think it over that what is the inventory, what is the level of their qualities. Of course, these are all our industrial materials generated. So they will have a lot of impurity levels, maybe heavy metals also. They need to be taken care for the purpose of health issues. And they have to understood that which is the best way out, where they are to be used. So if we do not do it today, probably again, after 10 years, 15 years, we will be in a situation where we will again say, sorry, we have already consumed this material for that purpose, which we could have used it in a much better way in some other application. So that is the need of the hour. And we are, as a NCB, we are fully capable, both infrastructure-wise as well as expertise-wise, to undertake any research and even formulating the guidelines also, which may contribute for policy formulation for the country. So this is from my side. Thank you, sir.
Yeah, thank you, Dr. Chaturvedi, and something very thoughtful that best way of use. Tomorrow we should not regret. Perhaps that would have been a better alternative. Something again, the best available technology also, that we continue to scan that what are the most suitable, best available technologies for current requirement, but current requirement as well should, really have a good perspective of the future also. So with these, so we, all the panelists, perhaps we had enough, without any restriction of, we already expressed our views. Then I would quickly, that out of this conversation, say some new thoughts or something to be, shared with. From my left, I would request Mr. Patel to, express something that what new insights or what new thing he wants to share with the audience and panelists.
Thank you, sir. I was thinking
and
that
this will go sequentially, like from this side to say 30 seconds, a minute or so. Yeah.
Sure. Thank you, sir. Actually, it's nice that I got another opportunity to speak. The main thing is that the generation of this phosphogypsum, if that can be avoided, that will be the great service to the nation also. And that's why IFFCO has patented one product which has been developed after a lot of R&D work. And we have now gone into a production of nano fertilizers, where if I just compare that 500 ml of nano fertilizer bottle is equivalent to 50 kilogram of a fertilizer bag. And equivalent, now if I consider this as a phosphoric acid requirement for nano fertilizers, then for ton of fertilizer, we are producing for 1 ton of fertilizer, 2000 grams of gypsum. But if the nano will come, then this per ton of fertilizer equivalent, the gypsum generation will be only 70 grams. So there will be a drastic reduction in generation of phosphogypsum if we replace the conventional phosphatic fertilizers with nano. The second best good thing what I foresee is that the support from BIS, NCCBM, even NCCBM has started their laboratory in Odisha. We are working with them. We already provided them the raw materials, especially the gypsum, and they have worked out. I'm very sure that Dr. Mahapatra was telling me that very soon they are going to come out with a paper where we can make use of this gypsum for other products also. So like that, we are getting support from CRRI and other institutions where there is a big knowledge bank, and we will definitely would like to use it and proceed further with utilization of phosphogypsum. Thank you.
Yes, Dr. Neeraj, what is our takeaway to NITI?
Sudhir ji, thank you so much. you have obviously tweaked the second part of the session. So now we are posed with some surprise questions.
I am forced to tweak the session.
Right, thank you. No, see, I should have spoken about this earlier also. Carbon capture, utilization and storage. Now, this is something which is very actively being pursued in the NITI Aayog and in the Government of India in general, in all the ministries and the concerned departments of the Government of India. We talk about the PM has given us the aim of achieving net carbon neutrality by the year 2070. Now, that will be possible not by the use of renewable energy alone. It will be possible only if we continue to do business as usual, but ensure that whatever so-called unclean fuels that we are using do not emit a single kilo of carbon dioxide to the atmosphere. Now, how do we do that? See, carbon dioxide is emitted from, from the cement industry, from the steel industry, from the power industry, and these are considered to be hard to abate sectors. There are technologies that are now coming up. We are talking about underground fixation of carbon dioxide. We are talking about underground sequestration of carbon dioxide and biological fixation of carbon dioxide, and most importantly, converting carbon dioxide to useful products. Methanol economy is pursued very actively, as Sudhir knows, by the S&T vertical in the NITI Aayog. And carbon dioxide to the methanol is a very good route to convert carbon dioxide to a useful product. And methanol to hydrogen, which will obviously be green hydrogen, which is also spoken about by the country in a big way nowadays, will be another useful product that can drive the hydrogen economy. So while we are looking at abatement of carbon dioxide in these three sectors, especially the cement sector, we need to continue to work on technology development through our very useful and very important laboratories that we have in the government system, in the private sector, in the academic system as well. And we need to ensure that we are able to translate these technologies to these so-called R&D technologies to deployable technologies with the participation of the industry. With that, I will finally say that we can also look at, as Sudhirji told me, the thermal substitution rate in the cement sector is gradually going up. From 0.6% about 12 years ago, it has risen to almost 25% in some cement industries, the average being around 4% to 13%. Now, thermal substitution rate means you use energy sources that are primarily renewable. I would extend that logic to say that other than renewable, let us look at energy technologies which are using carbon or using coal for power generation, but are being used in a very environmentally benign and a very sustainable manner, and are being used very responsibly by looking at technologies like advanced ultra-supercritical technology for thermal power generation, where the steam temperature goes to around 710 degrees Celsius, and the steam pressure goes to around 300 bar. And going by simple Carnot efficiency, the efficiency rises from around 41% in conventional thermal power plants to almost 46%. And with these plants, we can also look at replacing the so-called old and retiring plants of the NTPC and of the other utilities in India. And hence, look at thermal substitution rates going higher and higher in the cement sector and all the sectors as well. Thank you.
Yeah, thank you, Singh. And Professor Singh, that you gave a kind of idea that something like we should think on the man-made resources. So these all are, mid-term to long-term agenda that where you have to connect different dots, your ideas, translating it to the viable projects, connecting to the industry. So do the IIT or your group have some kind of perspective, how to realize that kind of ideas? Just giving a...
Thank you very much. I would request delegates to go through the web page of mine and my research group to understand what all is being done. In simple words, we are trying to educate the future generation to understand that there is nothing known as waste. This is all man-made resource where the sustainability comes in the picture. A lot of success stories have already been written in the form of technical articles in form of patents and so on. What Dr. Chaturvedi ji was talking about. I remember 20 years back, atomic waste disposal was supposed to be a future source of, getting niche radioactive material. So it was not supposed to be a waste. So what we are doing is, at the mine backfilling, when we are using the industrial waste, we are sensitizing the ministry also with MOEFCC and CPCB. We have successfully conducted experiments at Hindalco, Utkal, where we are using red mud for mine backfilling without CCUS, what he was talking about. So we are not mineralizing it, because at the back of the mind, we have this feeling that tomorrow some technology will come, you can extract vanadium, titanium, and the resource materials from the red mud. Municipal solid waste has been in our radar. And what we are doing is, we are trying to create different type of aggregates, what you were talking about. So these aggregates are maybe waste material from the landfill, biomined material, and the inert material like RDF, what you call. And we are converting them into man-made resources. Another thing which is a success story is about rejuvenation of the soil by using nutrients of different types. So in nutshell, what we are trying to do is, we are trying to collaborate with different ministries. And what FGD Gypsum is one of the success story under the leadership of Dr. Gupta. We are talking now with the Ministry of Port, Shipping and Waterways, Ministry of Agriculture, Ministry of Power, and we are trying to create a niche material which can be utilized for different applications. Yes. At academic institution, what we require is, we are Dronacharyas, Chandraguptas. We require more Chandragupta Mauryas, whom we can entrust with the task of creating different type of satellite units. And this is where the circular economy will come into picture, marketplace, who can delegate our ideas to realize the material or realize the project. So this is the role of the academicians where we are heavily involved with. Thank you very much.
Yeah, thank you so much, Dr. Singh. And I would request for a short intervention on the, kind of blended cement being talked about a lot in the country. Some groupings and all that, they say that this is the direction that India should take. What's the take of BIS on the blended cement, where higher ash and all that other slag and all that, done with?
I think, thank you. First of all, on use of slag, you can use 90-95%. Standards permit that. So we already have a standard, IS 6909.
For blended cements?
And that is blended cement. Yeah. This is blended cement. Blended cement can be fly ash based, blended cement can be slag based, blended cement can be mix of the two. So there is no limit in fact. And for use of fly ash, there is a limit of 35% in Portland pozzolana cement, but there is no limit in use of fly ash in concrete. So because once you design a high strength, high performance concrete, we leave it to the designer to manipulate the various blends, including the fly ash and other blends and certain minor constituents. So there is no limit to that. So that can be used in concrete making, especially in ready-mix concrete plants. So that is there. And we can see, in fact, I'll say that a lot of work is going on throughout the country in different research institutions like NCB. And the work of BIS depends on those outcomes. And we are prepared to utilize fully, and we are working hand in hand with them for standards development there. Another area I would like to mention here is that the waste producers can come out with suggestions to for value addition to their waste itself. For example, NTPC manufactures fly ash based paver blocks, fly ash based blocks, fly ash based bricks. Even their bricks, fly ash based bricks, is certified by BIS. So, and they are going for their other plants also to get that certification. And similarly, the construction sites have been using. There is one case in Kidwai Nagar where that NBCC has used all C&D waste generated at the site itself in manufacture of various precast concrete products using their own waste. So zero waste was created. So they will have to transport, if at all they have to transport a high value added items. So we'll have to work on various fronts, all these things. And BIS is prepared to, is geared up to make any kind of standards, amends to these standards, and revise these standards, create new standards wherever these are required. Thank you.
Yeah, thank you. And open-ended questions to last three panelists. Means it's a very mixed kind of conversation we had today, and the kind of possibilities we have for circular economy adoption in the cement side and the kind of developments. And your institute, towards road, what new areas you look forward, say, being a infrastructure road, being a very material intensive, what kind of new opportunities you look for, like C&D waste and applications of these areas?
In fact, I would like to add that currently at CSR level, one research project is created, Waste to Wealth. Honorable Prime Minister being the president of CSR Society, there is a mandate of Waste to Wealth. So some more than 5 CSR laboratories are collaborating to develop this project. So besides road construction, development of paving blocks, so all those things are part of that, and even the characterization of the waste, because different kinds of waste will require different kind of technology. And typically in this, say, multi-laboratory project, industries are encouraged to participate. Only one last thing I would like to say, that in rural roads today, there is immunity if a new product is being used or if a new trial is carried out. But we do not have the same immunity for serious highway projects. We claim that we are constructing more than 30 kilometers of national highway every day. So is it possible that 10% of that stretch can think of experimenting, can think of utilizing various kind of waste materials? That is to be thought through, although there was discussion that there could be competing uses. But then if you have clear-cut objective quantitative targets, the usage can be faster. Thank you.
Thank you. Quantitative targets, that drives us. That's what we are thinking, that to set targets before the industry, before the fertilizers plants, and so that we can aim higher. And again, I would request here the Ms. Basu, that challenging the industry, that was the kind of thoughts I picked up from your conversation, that how you really, what more challenges should be there, or it's a self kind of targets, or some of them should come from the regulation side, or what should set our targets?
Sudhir, just to give a flavor of how we are challenging ourselves. So as I said, in cement, there are a lot of established processes, a lot of things that's happening in its own steam, and we are committed to driving improved numbers. But just to give you an example, I think about 3 or 4 of our concrete plants, we are able to do 8 to 10% of sand substitution with C&D waste. What is limiting us taking it to our 52 plants is the availability of recycled C&D waste. So I would, we've had some very good discussions, and not like to revisit the measures which are very good. But if we step back and say that pushing the next level of circular economy needs a certain filtering lens. And I would give a simple takeaway for the audience and ourselves, that if we use something like a 3C model, cost, convenience, and collaboration. If ideas are filtered on this 3C model, then we will see more economic transition, and we will see better speed in the circular economy acceleration. So I'd just like to leave that and be conscious of the 30 seconds that you have given us in this last round. Thank you
Yeah,
so much.
Thank you so much again. And 3C ideas that can be collaboration is the key thing out of 3C that we try to do it in all our initiatives, and that's the key in many of the Western countries, European countries, that circular economy is not possible without having very, very close relations downstream, upstream, and other key participants. Say, again, I'll come back to you, and maybe if you have one or two good thoughts to my last side, Dr. Chaturvedi, yeah. How
So,
you want to like to close? Maybe audiences to. I just want to say that I will not be able to summarize what I noted. It runs in 3 pages, and I think that audience are not having, will not be, getting enriched by my summarizing the thoughts, because they are quite diverse. So I would request that Dr. Chakravarti to summarize also, as well as to, if he wants to add any new thing in a very short.
thank you, sir. I'll be short. See, sir, the contribution of young minds in the development of any nation has been phenomenal. We have seen that. So, considering that aspect in mind, we have started using the young minds, and in all our those challenging areas where we find difficulties and finding solutions. And for that purpose, we have entered into MOUs, not only with international organizations like SINTEF in Norway, or our leading institutions in the country, IITs, NITs, and all those institutes which are interested to work in these areas. So we have identified and we have entered into kind of MOU, and we are taking the help of those young people, picking up the ideas and giving them support so that they can contribute towards the nation building. This is what I submit. Thank you, sir.
Thank you, Dr. Chakravarti.